Time for some global ecology. Let's take a look at climate and biomes. Be able to define a Hadley cell and be able to draw that on a map of the globe. Identify high pressure and low pressure latitudes on a map. Relate seasonal variation to planetary tilt. Be able to define things like rain shadow and lake effect, and describe the moderating effect of water bodies on temperature. Be able to draw or label the Earth's major biomes on a map. For each terrestrial biome, describe temperature, precipitation, and seasonal variation in a short essay. Do note that this online video is not going to go into each biome. That will probably be an in-class activity. This is global ecology, so we are moving on from the study of animal behavior and musculature to the study of the whole globe, and it's the functioning and distribution of organisms across the biosphere. Let's take a look at that biosphere. Oh, there we go. You notice that deserts tend to be around 30 degrees north and south. You notice that tropical forests tend to be near the equator. Polar ice exists, well, at the poles. And then you have grasslands and coniferous forests, but those are only at certain parts of the world. So the question comes, why? Well, that has to do with global climate patterns, and that is largely determined by two things: the solar radiation and the movement of the planet in space. Solar radiation will warm the atmosphere, land, and the water. And most things that we're going to be looking at in terms of biomes and in terms of, well, global ecology in general are going to have to do with solar radiation to cause them. It's most intense when the sun is perpendicular. That's directly overhead. The tropics is the equator plus or minus 23.5 degrees. Those are the areas where the sun is directly overhead at least some point during the year. The highest solar radiation is there, and the lowest amount of seasonal variation is there. The seasonal variation is greatest at the poles. They have some points where the sun is not visible at all, and other points where the sun is visible all day long. The sun initiates air movement, and here's how. You have the sun directly overhead bringing down solar radiation. That solar radiation is going to warm the ground, and as the ground warms, it will warm the air nearby. Warm air is going to rise. And as hot air rises, it's going to expand. That expands is going to distribute the heat over a large area. That's also going to cause the air to cool. And as it cools, it's going to descend. As it sinks, it's going to go into these new locations because it can't sink directly over where it rose because there's still more hot air rising up. So you see it distributed farther away, and then it's going to replace the rising hot air. So these are going to be certain types of cells, and these cells are also going to impact rainfall because as warm air rises, it cools. As air cools, it can hold less water vapor. As it can hold less water vapor, it releases it in the form of rain. This is why a large amount of rain falls in the tropics. This is why also you'll see very hot days are going to lead to the movement of air up, and that is going to cause thunderstorms in certain parts of the world. Air is going to flow towards the poles from the equator because, as you saw, it can't just sink right back down. It's going to move laterally. That's going to be moving to the north and to the south. And as it cools, it has lost that moisture at the equator, and as it cools and moves, it's going to descend. As it descends, it becomes less dense. As it becomes less dense, it can pick up more moisture and it will heat up. Remember that this is going to be a kind of triangular or conic section, so as the air is moving away from the pole, there's a higher amount of volume available farther away from the Earth, and that volume decreases as the air goes towards the Earth. And as gas is going to compress, it heats up and can take in more moisture. That is why places like 30 degrees north and south are going to be relatively dry. This is what we see. We see the equator, or here the Intertropical Convergence Zone, or ITCZ. Wherever the ITCZ is going to be where you have hot air rising and releasing moisture in the sense of rain. It's going to be very hot, very wet. It's going to be abundant precipitation in all seasons. At 30 degrees north and south, you're going to have that subtropical high. That's high pressure as the air is descending, and it's going to be dry in all seasons. And this causes what we call Hadley cells. Hadley cells are those two circular cells starting at the ITCZ and moving up towards the 30 degrees north and 30 degrees south. Those cells are actually going to generate the movement of air to make another cell to its north, and then the final cell is going to be your polar cell, which is going to be at the poles. The polar high has low precipitation during all seasons. The subpolar low has ample precipitation in all seasons. You can see that in the taiga and temperate deciduous forests and grasslands. Then you have places with wet winters and dry summers, like where we are. Subtropical high, dry in all seasons, is your deserts, and the summers are wet, winters are dry. That's going to be where the ITCZ is going to be moving up. And, well, why is the ITCZ moving? Well, that has to do with the tilt of the Earth. The Earth is tilted, and the Earth is tilted relative to the sun. What that means is that the northern hemisphere gets winter as it tilts away from the sun, but as it's tilted towards the sun, it's going to get summer. That means that where the sun is directly overhead is actually going to move by 23.5 degrees. On June 21st, you actually have the sun directly overhead 23.5 degrees north. And on December 21st, you have the sun directly overhead 23.5 degrees south, meaning the intertropical convergence zone is moving north and south as the Earth moves around the sun. So that is a movement of the planet through space causing yearly variation. There are also local features of the landscape affecting climate on a regional scale. Here in the Pacific Northwest, we don't really get very cold during the winter, and we don't get very hot during the summer if we live on, say, the Kitsap Peninsula or the islands of Anacortes. When instead, the proximity to water is going to affect the temperature. It moderates the fluctuations in temperature. Water has a high heat capacity. It loses heat slowly and gains heat slowly, thus moderating fluctuations in temperature due to seasonal variation. We also know that more water can evaporate over water than over land, so areas closer to water will get more precipitation. That is going to cause two things. First off, lake effect weather. If the water temperature is warmer than the temperature of the land, wind will move over the water, and that wind will pick up moisture from the water, and as that wind moves over land, it will cool, and as it cools, it holds less moisture, and it holds less moisture, it will precipitate, often in the form of snow. This is lake effect snow. Another part of lake effect is when water temperature is cooler than the land, such as during the summer, the air will warm over the land, and you end up getting clear skies. So a place like Buffalo, New York gets very snowy winters and relatively dry summers. The rain shadow is something we're more familiar with here. That's a regional effect where moist air will move from over the water to over the land. We get our storms coming from the Pacific Ocean. The air must rise to go over the mountain ranges of the Cascades. As it rises, it cools. As air cools, it can hold less moisture. As it holds less moisture, it releases it in the form of rain. That causes heavy precipitation on the windward side of the mountains. On the other side, the air descends. As it descends, it heats up. As it heats up, it can hold more moisture, causing a desert in eastern Washington. See here the rain shadow effect on the Olympic Peninsula. On the leeward side of the mountain, the cool air is descending and making places like Port Townsend pretty darn dry. Port Townsend is not a desert. It's just very dry when compared to someplace like Forks, where it just won't stop raining. So we can see on there, Olympia, it's pretty rainy, but you can actually see that the coastal range, which is between Aberdeen and Olympia, is going to take up some of that moisture and actually make us in a slight bit of a rain shadow. Biomes are caused by the abiotic factors, namely precipitation and temperature. A desert has a range of temperatures. It can be warm, it can be cold, but always has low precipitation. A tropical forest can have a range of precipitation, but always has a high temperature, and always has a higher precipitation than a desert. You can also see that there are overlap between biomes. Before I taught at Lacey, I taught at a place called Bloomington, Illinois. And if you were to put that on this chart, you'll see that it has an annual mean precipitation of around 75 centimeters, and annual mean temperature of around 14 degrees Celsius. That puts it somewhere between temperate grassland, tropical temperate broadleaf forest, and northern coniferous forest. It really depends on a couple things. For example, how many fires there are. When Native Americans cultivated the land of Bloomington with fire, it turned into a temperate grassland. As settlers began planting broadleaf trees, it became a temperate broadleaf forest. It could be a northern coniferous forest if there were drier summers and wetter winters, which is what we end up getting in Lacey. Drier summers, wetter winters make it either a northern coniferous forest or a temperate broadleaf forest. It's the seasonality that begins to matter and pushes it towards northern coniferous forest because conifers do better in dry summers. Now, we're not going to look at all the biomes in this lecture, but you're welcome to come to class. We'll read about them in the book.